Hi there folks, so we are on Monday, aren't we? Yeah, good old Mondays. And we're going to be doing stuff looking at mixed numbers and top heavy fractions and converting between the two of them. So when you're dealing with not a whole number, but you've got more than one. And how do we say that in terms of fractions? And it's one of those things that once you've seen what's going on, it's quite simple, but it's trickier than you think, sort of thing. So you've got to think it through. So we're going to use rectangles again of a slightly different kind to show us how we're going to do that. But before we do that, I've got a nice little number square starter for you. Here's our number square, it's called, because within here there are 9 spaces. 2 of them have been done already with the 2 and the 8. So I think we did one of these before. So we need all the numbers. We've got 2 done already, 3, 4, 5, 6, 7, 8 done, and 9. And working from left to right and top to bottom, they've got to make the results that we get down there. So no BIDMAS involved. So what's going to make sense here? Well, I know that these two numbers have got to add up to make 10. I know that if I'm taking 8 from something, these two numbers have got to be multiplying together to make 3 to take 8 away and get -5. 3. So I know that it's either going to be 1 and 3 or 3 and 1 will be, those two numbers are going to go there. Now that doesn't rule us out, because this could be 1 plus 9 or it could be 3 plus 7. So I'm not sure which one of those that's going to be yet. How about down here? Anything ending in a 5 with a big, I'm thinking we're quite possibly going to be multiplying by 5 there, but those two could add up to 5 and be timesing by, well, that would have to be timesing by 13, wouldn't it? So 5 times 13 makes 65. So I'm thinking these two numbers probably add up to 13. We know that if this has got to be a 1 or a 3, this has got to be, to make 10 from that, either a 9 or a 7. So is there a choice of numbers that would give me 13? 9 add 4 is 13, or 7 add 6. So they both still work as well. What about this? Well, we've got to multiply by numbers to get something as big as 84. So when you're timesing, it doesn't matter what order you do it in. So because we're timesing by 2 there, half of that, 42. I need two numbers that multiply together to make 42. Well, they are definitely 6 and 7. Not sure which way round they go yet, but because I'd have to have 3 add 7 there, if I know that 7 is either there or there, that means it can't be here. So I'm going to take the plunge and say that's going to be 9 plus 1 is 10. Then I times 3 by 1 to get 3, which I take away from there. Now I'm thinking it's either got to be a 6 or a 7 there, and I'm timesing by something by 3. We've got rid of the 3 and the 1 and the 9. So it can't be 3 times 6, because that would get me up to 18. It could only be 3 times 4 or 3 times 5. And oh, remember what we said about this? We're going to be multiplying by 5. 9 plus 4 is 13. Right, 3 times 4 is 12. 12 plus 6 is 18, which means this must be the 7. Just checking. 12 times 7 is 84. 8 take 5 is 3. 3 take 7 is -4. They add up to 12. I know that already. Yeah, I reckon we've done that, folks. Right, time to move on and look at some fractions. Before we move on to mixed numbers, let's just have a little look at just reviewing what we did last time and see if you can do this. So pause the video and see if you can answer this question for me. Which is bigger, 5/7 or 3/5? What is 5/7 plus 3/5? Use some rectangles like we did last time, please, to show how you did it. Right, now, so hopefully we've got the fact that we've got 7 and 5. Now, so that it fits in easier, I'm going to do my 5 across and 7 down. So the two denominators are giving me the size, the dimensions, 5 across there and 7 down there of my rectangles. So I'm going to say right that, or go down 7 and across 5. So my 5/7, 7 is going down here, so I've got 7 rows. So I want 1, 2, 3, 4. Right, well, I'm going to cut them all into sevenths. That way I'm going to cut them all into fifths. That way, and then I'm going to highlight me 5/7. So it is 1, 2, 3, 4. Oh, I'm going to have another row, aren't I? 5. As opposed to 1, 2, 3. Now, just looking at that and the fact that I had to do 3 of them next to each other, I'm thinking 5/7 is going to be bigger than 3/5. I know they're both a bit more than a half, but how much? Maybe I should have done 4/7. Anyway, too late now, we're on it. So 5/7 equals something over what? How many squares have we got here? Well, it's 5, 10, 15, 20, 25, 30, 35, which is 7 times 5. We've cut all of the pieces into 5 smaller bits, which means we need 5 times as many of them. If you count up all of those, you get 5 5s are 25. And then doing the same idea over here, 3/5 into 30/5, because we've still got the same number of squares there. The 5 has had to be chopped up 7 times. And that means that we need 7 times as many of these pieces. And we've got 21 over 35. So 5/7 is bigger, not bigger, bigger by 4/35. So quite a bit bigger. And what is 5/7 plus 3/5? Well, we can say that the 5/7 is 25 over 35 and the 3/5 is 21 over 35. Now that we've got the size of the pieces, the new denominator's the same, we can add how many we've got each time. So I've got 25 and I've got 21. That adds up to 46. Now this leads into what we're going to do this lesson, because we've got more than a whole. So one whole is 35 over 35, and we have got 11 more than that, which is why we can write this as 1 whole and 11 35ths, and that just means 1 plus that, and that's what we're going to be thinking about today. Why is that so? It might not make sense to you yet, but hopefully it will soon. So first up, this is what we're going to do: convert a top-heavy fraction to a mixed number. So you might have something like 9 quarters. So what would that mean? And the way we're going to think about this is we're going to think about it in terms of wholes. So because we're talking about quarters, 4 quarters, oh, that's 4, isn't it? 4 quarters make a whole. So that's 4 quarters. Here's another whole. That's another 4 quarters. So we've got 4, 8, and the 1 left over there is going to equal 9. So how many wholes have we got? 2. How many quarters have we got? 1. So it's 2 and 1 quarter. So I'm going to write I'm going to do another example. Actually, I'm then going to do 17 thirds by the same thing. Now you may think you can do this already. By all means, give it a go. See if you get it right. So I've got 3 in my whole. So how many? There's 3. 3 plus another 3 is 6 to make 2 wholes. I'm going to keep doing this. 9. until I get to 17. 9 plus 3 is 12. Plus another 3 is 15. And then I just need 2 more to get to 17, don't I? And I've got 1, 2, 3, 4, 5 whole numbers and 2/3. So is there another quicker way you can do this? You can, because 17 over 3 means 17 divided by 3. And if you go through your 3 times table, 3 goes into 17 5 times, remainder 2. And it's that remainder 2 that still needs to be divided by 3. So that's why it's 5 and 2/3. So it's up to you. You can use that method or you can use this method. I'm going to put a few on for you to have a go at now. Right, so I'd like you to write all of these as mixed numbers. So you're going to be ending up with an answer with a whole number and a fraction for each one of these, please. Use rectangles if you want to. You just use division if you'd like. I'm going to do some of them one way, some of them another. Pause the video. Right, so for this one here, I'm going to just think about it as how many halves do I need? So halves, we need 2 halves in the thing, so I'm going to use rectangles of 2. So that's giving me 2 plus 2 makes 4. Plus 2 makes 1, 2, 3, 4, 5, 6. And then our 7th one is just there, isn't it? So how many holes have I got? 1, 2, 3 and a half. Now this time I'm going to use division. So 22, that means 22 divided by 3. I'm going to go through my 3s. 3, 6, 9, 12, 15, 18, 21, 24. Oh, that's too far. So I don't have that many. I've got 1, 2, 3, 4, 5, 6, 7 3s make 21. And I've got 1 left over. And that 1 remainder is my 1/3. So that is the remainder. And it's better than saying remainder 1. Because when you say remainder 1, it's a different amount depending on how big the number is in the denominator box. Because the bigger that number is, the smaller it is when you share 1 amongst it. So if you're trying to share 22 sweets between 3 people, everyone can have 7 sweets, and there's going to be 1 that people are going to be arguing over. Now, if it was chocolate instead of sweets, you could probably cut that into 3 little bits, couldn't you? That's the sort of thing we're talking about. Right, moving on then. 31 quarters. So let's do this one as rectangles. So each rectangle is going to be made of 4 boxes because you've got 4 quarters. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Add another 4 is 16. Add another 4 is 20. Keep going. 24. Add another 4 is 28. 29, 30, 31. So at this point here, oh, sort of running out of space, aren't I? How many holes have I got? 1, 2, 3, 4, 5, 6, 7 times 4 is 28. And I've got 3 remainder, which is my 3 quarters left over. Try and get that bit out there. So 7 3/4. 101 over 10. Well, it means 101 divided by 10. Now you might just want to write 10.1 because that is one thing you could do, couldn't you? You could say that, but that's as a decimal. As a fraction, remember this is the tenths column, isn't it? So it's 10 with 1/10 there. And 10 tens are 100 with 1 remainder, so that's still your remainder as your numerator. So then if we do the same idea for 73 divided by 5 because I don't want to do that many rectangles. 7 goes into 73. How many times? Well, we could do a little bus shelter here, couldn't we? And that will make it quicker because 5 goes into 7 once with 2 remaining. And that's 2 10s, so this counts as a 20. So 5 into 23. 5, 10, 15, 20. 4 5s are 20 with a remainder of 3. So we're talking 14 with a remaining 3/5 left over. Okay, so that's top heavy fractions into mixed numbers. Right, and then the other thing we need to be able to do is go the other way. So I'm going to do a little bit of showing you this. Like the other one, there's 2 ways we can do it. The quick way with a bit of multiplication as opposed to division, and the slightly longer way, which may well help if you get confused by this thing, using rectangles. So we've got 4 2/3. So that means 4 holes, and as we're talking about thirds, each one of those holes I'm going to represent with a stack of 3 squares. So that's the size of my hole, and then I've got another 2/3 there. So each one of these holes has got 3/3 in it, hasn't it? So there's 1 2 3 4 5 6 7 8 9 10 11 12 13 14. I make that. So that means what it's asking us is how many thirds have we got here? 14. I did promise you a slightly different way, didn't I? So how about if we had 5 and a quarter? Well, you may have noticed that what I've got here is the 3 times table up to 4 3s. So quarters is the size. Every hole is going to be worth 4 of those. So I do 5 times 4. And when I've done that, I add the numerator, because that's how many we've got left over. So 20 plus 1, which needs to be divided by 4. So it's 21 quarters. So there's your 2 methods. And what I'm going to do now is I'm going to put a few of those, just 4 of them, and I would like you to have a go at doing those. And I'm not going to go through those now. I would like you to upload those for me, and then on Wednesday I will give you some feedback on it. Hopefully before anyone who loads anything up before Wednesday, I will feedback to you. Look out for that probably on class charts on either Tuesday or the Wednesday, and then I will go through it next time. Right, so here we go. So here we go. You can use rectangles if you like for the first couple. That works really well. It'll still work for the others, but it'll take you a bit longer. But take your time. If you want to take a screenshot of it and print it off and do it that way, you can. But to be honest, it doesn't matter even if you haven't got squares. You can still use the method I'm talking about. It doesn't have to be exactly to scale. Okay, well, give that a good crack, and I will see you again on Wednesday. Bye bye.